Okay. So we'll have a simple pendulum, okay, which is having some mass m, length L, which makes an angle theta with your y-axis. So this is your x-axis, this is your y-axis. So this distance, let us say, considered to be x, and this should be considered as y. What do we want? We'll have to solve this equation and we'll have to obtain the equation of motion. So in order to obtain this equation of motion, we want two quantities. One is kinetic energy and another one is nothing but the potential energy. So kinetic energy that involves the quantities as your pendulum that moves in a two-dimensional space. Let us say the kinetic energy, it is given as 1/2 m into x dot square plus y dot square. आता जर आपण पाहिले की 3 डायमेन्शनल स्पेस जे आहे की त्याच्यामध्ये आपण कायनेटिक एनर्जी लिहिली ती 1/2 m x dot square plus y dot square plus z dot square. But now your simple pendulum is moving in a 2-dimensional space, so you can have that kinetic energy T is equal to 1/2 m x dot square plus y dot square. And we'll have another thing, that is your potential energy. So that potential energy that is given in terms of mg, okay, into some quantities. Okay, potential energy with the effect of your gravitational force, or you can say gravitational acceleration. This one will have your potential energy that is given in terms of mg is equal to mg into this OA minus OC. Okay, just check it out. Mg is equal to this OA minus OC. Now, look at the diagram. What is the value of your OA? The value of OA as this pendulum that comes to this position when theta is equal to 0 angle, the value of OA is equal to L. So we have that point, that is V is equal to, this is mg into OA is nothing but L minus, we have to find out the value of this OC. Okay, what is OC? OC is this much of distance. Okay, and it depends upon this value of point. So how can we calculate this? We can calculate it by using this condition cos of theta. What is cos of theta? The cos of theta is nothing but y upon L. Or you can say this y is nothing but L cos of theta. First thing. What is sin of theta? The sin of theta is nothing but x upon L, or x is equal to L sin of theta. So that is your points. So what is this OC? The OC value is nothing but y, and this y is nothing but L cos of theta, and that's why your potential energy is nothing but this thing. So I can write this V is equal to mg into L into 1 minus cos of theta. This is one thing. What do we want? We want your potential energy x dot square plus y dot square. Now we have a value of x, we can find out x dot. We can have a value of y, and we can have a y dot. So I will just have a differentiation of this, and I can write this is y dot is equal to, okay, L as it is. The derivative of cos theta is nothing but minus sin theta. So this is minus sin of theta into derivative with respect to theta, that is d theta by dt is nothing but theta dot. Similarly, we can have this differentiation of x. This is nothing but x dot, and which is equal to L into cos theta the derivative, sin theta the derivative cos theta into this theta dot. So what do we have? We'll just put these values of x dot and y dot here, and we'll have a kinetic energy. And I can write this T is equal to 1/2 m into x dot square. This is L square cos square theta into theta dot square plus L square sin square theta into theta dot square. So what should be your final thing? The kinetic energy that can be 1/2 m into L square into this theta dot square. What should be in the bracket? Cos square theta plus sin square theta, that is equal to 1. And so you can have a kinetic energy T is equal to 1 half m L square theta dot square. This is V is equal to mgl into 1 minus cos of theta. What is the Lagrangian? The Lagrangian is nothing but T minus V. And so you can have the point that is L equal to 1 half m L square theta dot square, 1 half m L square theta dot square minus this is mgl into 1 minus cos theta. So we have finished the half step. अर्धा पार्ट आपल्याला याच्यामध्ये झालेला आहे. What we want the equation of motion, and so in order to solve this we want this equation in our proper form, that is in terms of your generalized coordinate and generalized velocity. आता हे जे काही इक्वेशन आहे ते आता आपल्या याच्या पद्धतीने इथे लिहिता आलं पाहिजे. So what we want two coordinates, one is generalized coordinate and another one is generalized velocity. Just check it out here. We'll have both the coordinates. ज्या ठिकाणी velocity आपल्याला दिसते theta dot असेल, x dot असेल, y dot असेल, z dot असेल, phi dot असेल, तर त्या ज्या काही quantities आहेत त्या कुठल्या असतात? जनरलाइज्ड velocities. आणि ज्या फक्त आहे तशा आहेत x y z theta phi, त्याला म्हणायचं जनरलाइज्ड coordinates. So we have an equation, that is the Lagrangian equation, and that we can write, that is d dt of, this is gamma L by gamma theta dot. What is generalized coordinate? The generalized coordinate is theta. The generalized velocity is theta dot. So d dt of gamma L by gamma theta dot minus this gamma L by gamma theta, and that is equal to 0. So that is our this Lagrangian equation. सगळ्यांनी लक्षात येते हे इक्वेशन महत्त्वाचं आहे, Lagrangian इक्वेशन. आणि मग आता ह्या Lagrangian इक्वेशन मध्ये काय काय पाहिजे? So what we want here, we want two things. The first thing is nothing but gamma L by gamma theta dot. The second thing is gamma L by gamma theta. So I just write first thing, that is this gamma L by gamma theta dot, that is equal to, we'll have to differentiate this. Okay, so differentiating with respect to theta dot, so 1 half m L square. Okay, m is constant, L is also constant, that is the length of your pendulum. So m L square into 1 half into the derivative of this theta dot square. So I can write this as 1 half m L square into this twice theta dot. So this is m L square theta dot, first thing. Okay, now what is the second one? The second thing is nothing but gamma L by gamma theta. Gamma L by gamma theta. So the derivative of first term is 0. Now the second thing, this is minus, this is mgl. पहली term mgl, the derivative is 0. दूसरी term minus minus, that will becomes plus. And so I can write this is mgl into the derivative of cos theta is nothing but minus sin theta. So this is minus mgl into sin theta. So that should be your value. Now what you have to do? You have to just put this value in your equation, Lagrangian equation. So I'll write it here. That is d dt of gamma L by gamma theta dot is nothing but m L square theta dot. Okay, this is minus. So this minus and this minus, that will become plus, and this is plus mgl into sin of theta, and that is equal to 0. So what is this? This will become ml square theta dot, the derivative theta double dot, plus this is mgl into sin theta, that is equal to 0. So I can write this as theta double dot. Okay, ml square transfer करून घ्या. So this becomes ml, that will get cancelled out. This is L upon L square, so this becomes G upon L into this sin of theta, and that is equal to 0. So this is the equation of motion for simple pendulum. But sin theta is very small, this sin theta that becomes theta, and so I can write this equation as theta double dot plus g upon n into theta is equal to 0. So when this theta is very small, that means when it comes out to be equal to 0, the sin theta that is almost comparable to theta, and so we can have that theta double dot plus g upon n into theta that is equal to 0. So if you can remember the period of this simple pendulum, मागच्या वर्षी आपण पाहिलेला होता. So that period is given as 2 pi into square root of this is L upon G. Okay, so this is the period of oscillation of the simple pendulum. आपण जे काही एक्सपेरिमेंट पाठीमागच्या वर्षी पाहिले त्याच्यामध्ये या गोष्टी होत्या. Now we'll have that point also in terms of your Lagrangian equation. So just remember the points. We have a simple pendulum that is moving in a two-dimensional space, and so you can have that 2 points in terms of cos theta and sin theta. So you just find out the two velocities x dot and y dot. So from that we'll have the kinetic energy, we'll have a potential energy with the effect of mgh. Okay, so you can have, this is the height, so this is given in terms of that angle, so L minus L cos of theta, and so you can have V equal to mgh into 1 minus cos of theta. If you want to solve this Lagrangian, what we mainly want the two things, that is nothing but kinetic energy and potential energy. If you know these two things properly, then we'll easily find out this Lagrangian, and from that we'll have to just define these coordinates, generalized velocity and generalized coordinates. So from that you just obtain your equation in that form and just put the values. Okay, so you just have the equation of motion. तर अशा पद्धतीने तुमचे हे जे काही